Good morning. Day 2 of this NeetCode LeetCode grind. I am working now on top K frequent elements that I'll pull up right here. How are you doing? Hope you're doing well. I just woke up. I didn't get great sleep because I was too eager to get to this LeetCode. So this is what it's looking like. I've gotten all 5. I've gotten 4 done already, and we're going to get into some mediums, starting with this one and then a few more. So, I haven't looked at any Python yet, so I might be a little slow. I don't care though, because it's all part of the experience. So, we're given nums and we're given k. An integer array nums and an integer k. We want to return the k most frequent elements, and we can return the answer in any order. So, the most frequent elements. So we have example 1. 1, 1, 1, 2, 2, and 3. And the k most frequent elements, 1 and 2, which k equals 2. This is weird because what I think initially is the most frequent element in this array will be 1, 1, 1. It'd be 1. And the output is 1, 2. That's weird to me. That doesn't make sense to me. So it's missing a small clarification. If there are multiple k most frequently appearing elements, you can pick any k of them. So the idea of the question is to find out the k most frequent items and not which element is k times repeated. So when the test case is 1, 2 and k being 2, you need to return 2 most frequent elements, which is apparently 1, 2, and the occurrences of each element doesn't matter as long as the order of the elements is to be printed is important. Let's take 2 cases here. Case 1, input 1, 1, 2, 3, and k equals 2. So 1 has occurred 2 times, 2 has occurred 1 time, and 3 has occurred 1 time. Okay. So the answer would be 1, 2. 1 has occurred 2 times. Okay, that makes more sense. And then this would be a tie case. So 1 has occurred 2 times, 2 has occurred 2 times, and 3 has occurred 1 time. So the answer is 1, 2, and if the order of the printing is important, the first 1 and the 2 and then 2 should be printed because 1 is less than 2. Okay. So in this case, we will have, this would be 1, 3. And this would just be 1 because it's 1 of 1. So when we get to coding this, we want to create a what did we find last time? A dictionary? It wasn't a dictionary, but it was a hash set, I believe. Not a hash set, but a hash map. Or no, it's a dictionary. No. No, it is a dictionary. I think we use a dictionary here. The key value pairs to count. So what we'll do is we'll get count equals this. What is this? What does this mean? Is that a dictionary? Or is it a hash set? What is it exactly? An empty dictionary. So we want to create a dictionary with key value pairs. And then we can determine a variable called frequency, where we loop through with I in the range of the length of nums and 1. And what this is going to give us is an array for the length of nums. So then we can create our key value pairs. So then we can go through the array of nums and we can look at the key value pair of n and equal it to our classic dictionary assignment. So if it doesn't exist, then we add 1. I guess, yeah, whatever it is, we get the value. We get the value for n and return 0 if there's nothing there. Otherwise, we add 1 to it. I guess we add 1 to it regardless. So then we go to the next line and we go through the n value and the c value in count.items, which is a call that we can use on dictionaries, and we're going to take the frequency array. Oh, this is what this is doing, is creating an empty array for the range of 0 to the length of nums. So when we create this empty array of frequency, we have our C, basically our enumerated list, or our enumerated dictionary, where we have our key value pair, I believe, and our actual value, or our actual value and then our enumerated value. So we can do frequency C dot append n, which will give us a new array where we're appending the values of n as they appear in count.items, which is the occurrence of each value. I'm missing something there, but it's okay. Then we can return the result, or create what will be the result, by using this array, because we're trying to return the k most elements. So we have our input of, say, this, and our k equals 2, and we'll have the number 1 and then a 3. That'll be the goal. So we can loop through I in the range of the length of frequency minus 1 and go in reverse order from the end and then as we're looping backwards through this range, we can look through the frequency array, so we can then append the value that we see in the frequency array to the result. And if the length of the result equals k, then we can return the result. So what this is doing is, if k is, excuse me, coffee time. If k is the most frequent elements, or the number of elements that we want to look for a frequency of, and we find the first one to be of that frequency, then we can return. And that, I believe, is what we're doing here. So let me think through just one more time. We have a count dictionary assignment, and then we have an empty frequency array for the range of the length of nums, which is the array that we're given, plus 1. Then we go through every value of nums, and we create a key value pair based on this value, and we add 1 for every copy that exists in the nums array, where we have this line that, we're doing a count.get for this particular value. If there's nothing there, we return 0 and add 1. And if there is a value, then it returns that value and adds 1 regardless. Then for all the values in count that we have added, like the instance of every number, we have n and we have c, where what we're doing is we're appending the values of n to the frequency of c as they appear in the array. So for the values of 1, that is going to appear in the 0th position in this frequency array. And for the 1th position in the frequency array, we're going to append the number of appearances, and then we're going to append the number of appearances in for 3 in the second Like 0, 1, 2, it'd be the 2 position of this frequency array. Then, once we have that figured out, we can look at the result, or we can create a resulting array to loop through once more, where we're looking at for I in the range of the length of this frequency array, minus 1, we're going to loop through the end of it by -1. So we start at the end and then we go back. And for each value in frequency, as we loop backwards, we're going to append n to it. We're going to append n to the result. So if the length of the result equals k, then we're going to return the result. Res.append n for frequency I. I believe I just want to see like what this would look like. So using ChatGPT, this is what we will find when we plug in the input nums 1, 1, 1, 2, 2, 3, and k equals 2. So the top k frequent function is called with the arguments nums and k. Nums is the list of numbers and k represents the number of most frequent elements to return. That makes sense. A dictionary name count is initialized as an empty dictionary. This will store the frequency of each element in the nums list. Okay, that makes sense. A list named frequency is initialized with empty list for each possible frequency. A list of frequency is initialized with empty lists, this one. So these are sublists, basically. The length of frequency is one more than the length of nums, in this case 7, and it will be used to store elements based on their frequencies. The elements with the same frequency will be in the same nested list. Okay? The first loop iterates through each element n in nums, and for each element, the code updates the count dictionary with the element's frequency. So we have our key value pairs, 1 corresponding to 3, 2 corresponding to 2, and 3 corresponding to 1. And then the second loop here, the n and the c, iterates through the key value pairs and the count dictionary, appending the key for each item to the nested list in frequency, with the index equal to the value of frequency c. So after this loop, the frequency list will look like this. Blank, 3, 2, 1, blank, blank, blank. Which is interesting. I'm not quite sure. Then an empty list named res is initialized, which will be used to store the final result, the top k most frequent elements. The third loop iterates through the frequency list in the reverse order from the highest frequency to the lowest, which is from the back to the front. And for each nested list, frequency I, this is each nested list, it iterates through the elements n and appends them to the resulting list. So then while iterating through the elements in the frequency list, the code checks if the length of the res list has reached k. If so, it immediately returns the res here when the function returns the res list as the result. In this case, the res list will be 1, 2 when the function returns. Because 1 and 2 is what we see here. The k, but this is still weird to me. The top k frequent elements. Yeah, there's still a few steps in here that I don't really understand. I want to know what a better question would be to ask for my confusion, because I know that with better targeted questions, I can learn more effectively through inquiry. So a list name frequency is initialized with empty list for each possible frequency. Okay. The length of frequency is 1 more than the length of nums. This list will be used to store elements based on their frequencies. So what this is assuming is that there could be a frequency of 1 for nums. So this could be 1, 2, 3, 4, 5, 6 values. It could be 1 through 6. Or actually 7. 0, 1, 2, 3, 4, 5. Wait, 0, 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. So it could go from 0 to 6, which is 7. I believe. I think that's right. I don't know. Why do we do this step? Make it emotional so I retain it better. So imagine I'm at a party where I'm the where I'm the only one not dressed up as a number and everyone else is dressed up a number. I feel like I'm completely left out. You know, I'm not even a number, but the more frequently a number appears in the nums list, the more popular that number is at the party. So I need to find the k most popular numbers. So to make this task easier and more organized, I decided to create separate areas in the frequency list for numbers based on their popularity. And I want to make sure I have enough areas for all possible levels of popularity. So I create one area for each possible frequency from 1 to the maximum possible frequency, which is the length of the nums list. I also can add one extra area just to be safe, making the total length of frequency 1 more than the length of nums. But why do I add 1 more? Now with this well-organized setup, I can visit each area starting from the most popular area, because it's already organized, collecting the k most popular numbers to complete your task. Why do I do this? But I want to know why. What would be the max? What would be the each possible frequency? Oh, here. You create one area for each possible frequency from 1 to the maximum possible frequency, which is the length of the nums list. Why do I add one extra area? Why does there need to be an extra area added? So 1 to the length of nums. But it just gives me a word of caution. So it's like a best practice, so I don't get an index error working with the frequency list. So it's just an edge case. That is best practice. Okay. So then I can go here, back up here. So we have our length of nums and our edge case for index errors. For n in nums, we can go through the count of n. I know what this does. And then n comma c. What does that do? So this goes through the key value pair items, which is what I thought, count.items, where n represents the key and c represents the value, the frequency of the element in the nums list. So for each key value pair, n comma c in the count dictionary, the loop appends the key n, the element, to the corresponding nested list in the frequency list based on the value c, the frequency. So n is the element, and c is the frequency, which is the corresponding value. So when we append the element n to frequency c, we are sorting the elements based on their frequency. So let me try to visualize this in my mind. Element n, which could be any number, to frequency, or n could be, n is the element, c is the frequency. So the higher the frequency, we can sort the element. Okay? Then after the loop, the frequency list will have the element sorted into separate nested lists from high to low. Because this occurs 3 times, this occurs 2 times, or this, so 3 occurs 1 time, 2 occurs 2 times, and 1 occurs 3 times. So the element 1 has a frequency of 3, so it is placed at the nested list at index 3 of the frequency list. And similarly, I think that's wrong. It's not, if this is the frequency list, then this is at 3. So, but it's, I know it works in my mind. So this just organizes the count items. It organizes them by frequency. So then we can look at this block of code. Gathering the top k most frequent elements in the frequency list and returning them as the final result in a list named res. Okay. So we are going in reverse order, starting at the length of frequency, going down to 1. We're going down to 0. Yeah, we're going down to 0. The loop moves in the highest frequency to the lowest frequency. And if the length of the result is k, then we can return the result. Ooh, I think I get it now. It collects the k most frequent elements. So if these are the most frequent elements, then it's going to give 1 and 2. That makes sense. If you have count equals 1 to 3, 2, 2, 3, 1, the most frequent elements appear at 1 and 2. Okay. So we're iterating through the top to the bottom. And if the length of res equals k, which is 2, we return res. And because it's sorted by frequency, when we loop through it the first time, it will give us the result right away. So it's the right answer. I know it's the right answer. But I just want to look through a solution. So this is like what I did. I think it'll be good to look at it in a different format. So we have this and a num and nums. We have this frequency, and we have a mini heap to store the top k frequent elements. This isn't really... Okay, this is not... I didn't use an if statement like this. I just used loops. You know, this is crazy to me how people can just make a one-liner. Let me just look at the video solution.
Hey everyone.
Wow, this is Amazon.
Let's write some more NeetCode today. So today let's solve top k frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write.
Wow, I'm actually getting smarter.
So we're given it in the answer in any order. So for example, we have this input array, 3 1s, 2 2s, and a single 3. And we want to return the 2 most frequent elements, right? So we know that the most frequent is, of course, 1. It appears 3 times, so we add a 1 to the output. The second most frequent is 2, so then we add a 2 to the output, and that's all we want. Now, if k was 3, of course, we'd add the last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So for example, for each value, right, we're going to count how many occurrences it has. So for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending order, right? So basically it's already sorted, solved in linear time if you use the like 3. So this problem can actually be solved in linear time if you use the algorithm called bucket sort. So when you first think of bucket sort, this is probably what you're going to think of. The way bucket sort is usually taught is that for each value, for example, 1, we're going to take an input array, right? This is our input array. This row is the indices, the index of the array, and this is actually going to be the value. So for example, for 1, we're going to go to the index 1, and in the value, we're going to put, okay, 1 occurs exactly once. Now we're going to see a second one, we're going to say 1 occurs twice, right? Basically, we're going to go through the input array, count how many times each value occurs, and then in our input array, put that count for that index, right? Map the value to the index and then put the count of that value. So 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now this algorithm would be linear time if our input values, right, were bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input array is also going to be 10, right? But in this case, the values are unbounded, right? Like this could have been 1,000,000, and then the size of our input array would have been 1,000,000, even though the total
that makes sense
input
because
array size.
What I was thinking was how I'm like, this is weird. It could be 0 to 7, it could be 1 to 6. But this could be any number.
It's only 6, right? We have 6 elements, but then that array where we actually store the bucket sort values is going to be unbounded, right? And also, we want the top k elements. This still isn't very clear of where exactly the top k elements are actually going to be. So in this case, this type of bucket sort doesn't work, but there's another way we can do it. So in this case, you can see for our array where we're going to be doing the bucket sort, the index I was using each value in the input array. For example, 1 was being mapped to index 1, right? And there we were storing the count. There's actually another tricky way that you can do it that will lead us to a linear time solution. So if we're pretty clever,
which is O of n, not O log of n or O n squared.
It's we're actually going to be mapping
O of n, because I kept messing that up
value,
in the past
in the values,
videos.
We're actually going to have a list of which values have exactly this particular count. List the count. What we're going to do for the index, we're actually going to be mapping the counts of each value, and in the values, we're actually going to have a list of which values have exactly this particular count. For example,
this is like the confusing part,
right?
Because there's like a weird flip confusion that
occurs
is
one
stuck
time.
in my mind.
So what we're going to do is for this position 1, we're going to say, okay, this value occurs only once. 100 occurs one single time. Which value, for another value in our input array 2, we see it occurs exactly twice, right? We can count that with a hash map pretty easily. And then we'll say, okay, this value occurs twice. So in the position 2, index position 2 of our array, we're going to add that value 2. 2 is the value that occurs twice.
Oh.
We see a last distinct value in our input array 1. We count it occurs exactly 3 times. So in this position, index
we have 1.
3, we're going to say, okay, there's a single value, a 1 that occurs 3 times. Now it's possible maybe we had a third 3, right? Maybe 2 occurs 3 times. In that case, we would actually have multiple values in this position, right? But in this case, we can see 1 occurs 3 times, 2 occurs twice, 100 occurs once. So they're all going to go in separate positions. And then, once we've taken every single input value and counted how many times each value occurs and then put it in the appropriate spot in this array, what are we going to do? Well, we want the top k values, right? The top k values that occur most frequently, right? So what are we going to do? We're going to start at this end of the array. We want all the values that occur 6 times. Why are we stopping at 6 though? Why don't I extend this array farther, right? 7, 8, 100, right? Why do the indices stop at 6? Notice something about our input array. Our input array is size 6, right? So that means if every single value in the input array was the exact same, the most number of times a value could occur would be exactly 6 times. So
Yep,
the
that makes
cool
sense.
thing about this new array that we're creating is it's bounded by 6, or well, technically 6 plus 1 because we do have a 0, but that's not actually necessary. But it's proportionate to the size of the input array, right? So when we're scanning from right to left, or however we do it, we're only going to be doing that. We can scan through the entire thing in linear time. Now, in this case, we see 6. There's no values that occur 6 times, so we can't find our top k element in that position. We'll try the same thing with 5.
So
5,
we go,
no values occur 5
we go
times.
from
4, no
back
values
to
occur 4 times.
front. We go from back to front because it's already sorted by the count.
3, a single value. We're going to go through every value in this array. There's only a single value in this case, but we do see a 1 occur. So to our result, we want the top k values, the top k occurring values. We are going to add a 1 to that. 1 occurs most frequently in the input array. So we add 1 to our result. We need 1 more because I think we were looking for the top 2 values. K in this case is going to be 2.
Yeah,
So now
so
we're
it
going to
could
go here.
be
Which values
the
occur
top K.
twice? A single value, and that value is 2. So we're going to add that to our output array. So now we've gotten the top 2 values, and then we can return this array. Now, why is this linear time again? Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we could have a value, for example, 1 could occur 6 times. In that case, we'd have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6?
Then you
in
return
that case,
all of them.
this position would be empty because no values occur 6 times, no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1. Reason being, each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here. And that's still going to be linear time because, yes, we are going to be iterating through this entire input array, which is going to be big O of n. And then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still technically linear time. Now, we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array, so the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time code. It's pretty easy once you can identify this trick. So we are going to use...
Okay, that makes sense.